Hello students, today we are going to talk about photoelectric effect. But before starting this lecture, make sure to like and subscribe to our channel. The photoelectric effect is a phenomenon where electrons are ejected from a material when it is exposed to electromagnetic radiation. This effect provided key evidence for the quantum nature of light and played a crucial role in the development of quantum mechanics. Let's see the key concepts. First, when light shines on a material, particularly metals, electrons are emitted from its surface. These ejected electrons are called photoelectrons. Second, for each material there is a minimum frequency of light, known as the threshold frequency below which no electrons are emitted, regardless of the light's intensity. Third, the kinetic energy of the emitted electrons depends on the frequency of the incident light, not its intensity. Higher frequency light imparts more energy to the electrons. Fourth, the number of photoelectrons emitted is proportional to the light's intensity brightness at a given frequency. Higher intensity light results in more photoelectrons, but their individual energies depend on the light's frequency. Albert Einstein provided a theoretical explanation for the photoelectric effect in 1905, which earned him the Nobel Prize in Physics in 1921. He proposed that light consists of discrete packets of energy called photons, and the energy of each photon is proportional to its frequency E is equals to hv, where E is the energy, V is the frequency, and h is Planck's constant. Let's check how it works. First, when a photon hits the material, it can be absorbed by an electron in the material. Second, the energy from the photon is transferred to the electron. If the photon's energy exceeds the material's work function, the energy needed to release an electron from the material's surface, the electron is ejected. Third, any excess energy from the photon beyond the work function becomes the kinetic energy of the emitted electron. This is described by the equation. Kinetic energy is equals to energy of photons minus work done. The photoelectric effect will only occur under these cases: if frequency is greater than threshold frequency, and if energy of photon is greater than work done. That's it for today's video. Until next time, stay safe and keep experimenting.